Okay, so what we had was a car. And it was traveling along at 40 meters per second. So let's call this V of the car. And a motorcycle, which waited 4 seconds, right? After 4 seconds of the car passing it, car passes it after 4 seconds, the motorcycle starts from rest. So the initial speed of the motorcycle is 0. And started accelerating at, what was it, 4 meters per second squared. So accelerating the motorcycle is 4 meters per second squared. And we had several questions, right? Where does the motorcycle catch the car? How long does it take? How fast is it going? Okay, so then we need to set this up. In order for the motorcycle to catch the car, we need their positions to be the same. So the position for the car be the same as the motorcycle. So this is our starting point. And then we need to figure out which clock to use, right? So there are a couple choices here you can do. The one I did is to say, I'll start the clock after the car has gone the 4 seconds. I'll say that's t equals 0 for both, okay? What that means then is after 4 seconds, the car is at a distance or a position, the initial position of the car, x naught of the car, would be 160 meters. How we got that is we have a constant speed, no acceleration for the car. Constant speed, 40 meters per second, right? 4 seconds, 160 meters. Okay. So therefore we can write out each side of this equation and then solve. Turns out we'll solve for time. So xc will then be the initial position of the car plus the speed of the car times time. Right? There's no acceleration, so that's it. On the right-hand side, all we have is the initial position of the motorcycle is 0. The initial speed of the motorcycle is 0. And therefore, we just have 1/2 a v squared. And again, I need to emphasize this is the same time. Okay, it's not that the car had 4 more seconds. If that were the case, then you'd have to shift what its initial position was, right? And then from here, it's just solving a quadratic equation. So if you want, you can do this symbolically, set it all up, put it in. You can do it with numbers. I tend to get pretty easy numbers, so we can go ahead and write that out. Let's see what this looks like. We then have 160, right, plus 40 t equals 4/2 is 2 v squared. I would go ahead and divide out by 2 at the same time that I will take these to the other side and get t squared minus 20 t 4/2 to the other side, and then minus 80. And then from there you can solve for t. You have to figure out which one of these is the physical answer. In this case, we had one positive, one negative, so it's the positive answer. It was 23 point something seconds. So recall the answer will be in seconds. This is all in seconds. And from there, where are they? You take this answer that you get for t and you can just plug it back into here. And that gives you the position. Okay. It was over a kilometer. And then at what speed was the motorcycle going? Well, for that, we need the speed of the motorcycle will be its initial speed, or this is velocity, plus am. So once we have this time, we put it into here. That gives us the position. We put it into here, and that gives us the speed. And remember, this is going to be in meters per second. There were a few issues with the units. This is in seconds, and then this one's in meters. At the beginning of a problem, if I were given something that's not in meters per second, I would transform it all into meters per second, and then I know at the end my units are going to be the correct ones. Right? Questions on any of these steps?